Hello, and welcome to the next video in my series on finite mathematics. Now, a few things before we get started. Number one, if you're watching this video because you're struggling in a class right now, I want you to stay positive and keep your head up. If you're watching this, it means you've accomplished quite a bit in your educational career up to this point. You're smart, and you may have just hit a temporary rough patch. Now, I know with the right amount of hard work, practice, and patience, you can get through it. I have faith in you. Many other people around you have faith in you. So should you. Number two, please feel free to follow me here on YouTube or on Twitter. That way, when I upload a new video, you know about it. And on the topic of the video, if you like it, please give it a thumbs up, share it with classmates or colleagues, or put it on the playlist, because that does encourage me to keep making them. On the flip side, if you think there is something I can do better, please leave a constructive comment below the video, and I'll try to incorporate those ideas into future ones. And finally, just keep in mind that these videos are meant for individuals who are relatively new, or brand new for that matter, to finite mathematics. So I will just be going over the very basic concepts. And I will be doing so in a slow, deliberate manner. Not only do I want you to understand what's going on, but also why. So all that being said, let's go ahead and get started. So this video is the next in our series on sets and counting. And in the videos leading up to this one, we talked about what sets are. We talked about elements of sets. We talked about subsets, both proper subsets and just normal subsets. In the videos preceding this one, immediately preceding this one, we talked about Venn diagrams, which depending on how your mind works can be blessing or curses. Most of the students I work with consider them a curse because it forces them to think in a way that's different than they're used to. So in the previous videos, we really took apart Venn diagrams. We talked about different regions and things of that nature. So this video is the first in a set of two videos I'm going to do about Venn diagram practice, where we actually walk through some problems step by step so you can see how I solve them and some tips I've come across over time that I teach the students I work with, and then you can apply those to your work. So let's go ahead and take a look at our first problem. Now, I will say, before we get started actually on the problem, it may be a good idea that when we come to each problem that you pause the video, write down the information so you can follow right along. Doing Venn diagrams in PowerPoint is not the easiest thing in the world, so I kind of had to do the best I can. So you might want to jot down the diagram, the information that's given, and then walk through step by step. Let's go ahead and take a look. So here is our first problem. Now let's take a look at the anatomy of the Venn diagram so we completely understand how it's laid out and what's going on. So the first thing we notice is that we have a universal set. That's everything within the square shape. So everything we're going to consider is inside that square shape. Now inside there we have three sets. We have set A, then we have set B on the lower right, and then we have set C in the lower left. And it appears they all intersect at various points. So we have the 10, the 2, and the 4. So we are given some basic information to work with. Now, of course, our job is going to be to fill in the missing regions. So you can see we have several missing regions. The majority of A is missing. The majority of B and C are missing. And then we have part of an intersection between B and C missing. And of course, we have everything outside of A, B, and C also missing. So there's quite a bit of information we got to fill in. Now, of course, in addition to what we're given in the regions, we are also given some more information. Now, the first thing we're told is that the number of elements in the entire universal set must add up to 50. So everything within that square must add up to 50. Now, we're also told that the number of elements in A must add up to 20. Now, we're given part of A because the 10, 2, and the 4 are part of A. They're part of other things too, but they're definitely part of A. So we can use that information to fill out our missing part. We're told the number of elements in B is 20. So if we look at the B set down there in the lower right, we have part of it. We're given the 2 and the 4. Those are part of B. The number of elements in C equals 28. So if we look at set C down there in the lower left, we have part of that. We're told that the 10 and 2 are part of C, but again, there are 2 regions missing there. Now we were also told that the number of elements in B intersect C equals 8. So the sort of the American football shape, kind of the oblong oval shape down there between B and C, that must add up to 8. So we can use the information we're given, both in the diagram and in the list over here, to find out the missing piece. Now, there are also some things we can figure out from the diagram that isn't given to us in the list over there on the right, but based on the diagram, we can come up with some more knowns. For example, we know that the number of elements in the triple intersection, or the intersection of A intersect B intersect C, there in the middle, we know that is 2. Now that was not given to us in the list over on the right, but based on the diagram, we can put that as a known. We also know that A intersect C is 12. So if we look at set A and set C, their intersection is accounted for with the 10 and the 2. So we know that A intersect C is 12. On the other side, we know that A intersect B is 6. So if you look at the A set and the B set, their intersection is accounted for with the 2 and the 4 over there on the right-hand side. So we have 4 unknown regions we have to find. Actually, 5, I'm sorry. We have T, which is up here in the A. We have U over down in the C set. We have V, which is in the intersection of B and C. And we have W, which is down here on the lower right. Now, in addition to this, and this is my fault, we also have one more. You know where that's at? Well, it's on the outside. So anything outside of A, B, or C is going to be in the region between the A, B, and C sets and the universal set sort of on the outside. So that's my fault for not putting that in there. I do apologize. Okay, so let's talk about how to find this first missing piece. So we're going to try to find the part of A that is unknown. Now we know that the number of elements in A has to add up to 20. So we can find that missing region using subtraction. So if the entire part of A has to add up to 20, we can subtract the 10 that's accounted for here in the left. We can subtract the 2 that's in the triple intersection there in the middle. And we can subtract the 4 that is common to A and B. But of course, it's still in A. So 20 minus 10 minus 2 minus 4 equals 4. So the number of elements in that missing region, that part of A that we didn't know, is 4. And that should sort of make sense if we add up everything we have. 10 plus 2 plus 4 plus 4 equals 20. So that's the first piece we found. Now let's try to find this missing part of the intersection between B and C. Well, we're given in the problem that the number of elements in B intersect C equals 8. Therefore, the missing region there in the blue has to be 8 minus 2, which gives us 6. So that missing piece is 6. So in our given, B intersects C is 8, so 2 and 6 is 8. Now let's find the missing part of B. Well, we know that B has to equal 20. Therefore, the missing region has to be the entire part of 20 that we're given, minus the 6, the 2, and the 4 that we already know. So 20 minus 6 minus 4 minus 2 equals 8. So the missing part of B is 8. Now we're going to find the missing part of C. So we know that C has to equal 28. Therefore, that missing region is 28 minus the 10 we know, minus the 2 we know, and minus the 6 we know. So 28 minus 10 minus 2 minus 6 equals 10. So we can put that there. So we're almost done. Now the next piece we have to find is outside, if there's any. So how do we do this? Well, we know if we add up everything that we have there inside A, B, and C, that is A union B union C. And if we add up everything in there, it comes out to 44. So if everything in the universal set is 50, and everything inside A, B, or C equals 44, then outside of that must be 6. 50 minus 44 equals 6. And that goes there. And guess what? That is the end of this problem. So before we do the second one, just some general things in mind. The easiest thing to do is just to make a list. Okay, and in the next video, I'm going to talk about that extensively. Make a list of everything you're given, and then make a list of everything you can find out from the diagram on your own. And then from there, it's just basically solving a puzzle. Okay, so you find the easy things that you can look at and say, hey, you know, I have everything in A but this one piece. And I know what A has to be, so I can find that one piece. And then you sort of go from there. So you find the easiest things first, and then go from there. Okay, so this is going to be a practice problem too, and this one's a bit more difficult because some of the things we have to find, we don't have a lot of information off, right off the bat. Let's go ahead and take a look at this one. Okay, so the same basic setup. So we have a universal set, which comprises everything of interest. We have 3 sets in the middle, A, B, and C, same thing as the last one. But then we have different pieces of information. So we have, outside of A, B, and C, we have 100. So outside of the union of A, B, and C, the elements are 100. But then we have bits and pieces of other parts of the Venn diagram. We have 2 parts of A. We have a 3 and 4 there. We have 2 parts of B, a 10 and a 4. Then we have 2 parts of C, a 15 and a 10. So you look at this and you're thinking, well, how I have 2 missing pieces for everything. How can I find that? So this is how we're going to do it. So here are some givens. The number of elements in the entire universal set is 140. Now, what we can discern from that, and it's actually given to us here, is that everything outside of the union of all 3, A, B, and C, equals 100. And that's down here in the lower right. But that tells us something else, which we'll talk about here in a second. Now, we're given that the number of elements in A equals 10. The number of elements in B equals 19. So again, if we look at A, we have 2 elements, or 2 regions out of 4. So we got to figure out what's going to add up to 10 there. With B, we know it has to add up to 19, but we only have the 10 and the 4 to work with. So, what can we find out just from what we have, which is not much, to tell you the truth. There's not much to go on at the start. Now, if the entire universal set is 140, and then the complement of the intersection of A, B, and the union of A, B, and C is 100. That's the 100 outside there. What does the union of A, B, and C have to be? Well, it has to be 40. So everything outside of that union of A, B, and C is 100. So everything inside has to be 40 to make up our entire universal set of 140. So it's the first piece of information that you can sort of discern from the diagram itself. So we'll go ahead and put that in our list of givens or knowns over here. So we have our universal set 140. We have the complement of the union of all 3 sets equals 100 down there at the lower right. That means we know that A union B union C has to add up to 40. The number of elements in A is 10. The number of elements in B is 19. So what can we do with this? Well, there are 3 regions we do not know. We don't know T here in the middle. We don't know U, which is over there in the intersection of A and C. And we don't know V, which is part of B. So those are the things we're going to have to try and find. Now the first thing we're going to do is we need to figure out a way to find, part of a missing piece. And one of the things that makes this Venn diagram challenging is that all of our sets, A, B, and C, have two unknowns in them. So we kind of have to work with what we have. Now, if you see what I've done here, what we know is that the number of elements in A has to add up to 10. So for that to be true, we know that the number of elements in this intersection here, which again, that is comprised of two unknowns, which we'll talk about in a second. But this little shape here in the green, well, that has to have 3 elements in it. So we can kind of put a 3 there temporarily. Now, we know that this region where the 3 is made up of 2 unknowns. But for now, that's not really important. This is just a temporary step, because when we fill in that 3 there, what does it allow us to find? Well, that allows us to find the value for V there in the lower right. So just this very simple acknowledgement that because A has to add up to 10, this little slice here on the left-hand side has to be 3. That would make A add up to 10. That frees us up to find V, which if you look at this Venn diagram now, that's the only unknown. That's the only unknown. So how do we find that? And I've gone ahead and colored it in blue here. What we know is that since A union B union C equals 40, we can use subtraction to find that bottom unknown. Should be bottom right, not bottom left. So 40, which is the union of A, B, and C, minus the 15 we have there, minus the 10, minus the 3, minus the other 3, minus the 4, leaves us with 5. So we know this region has to be 5. Now we could not have done that without this little trick of the part of A that is 3. That was the importance of that intermediate step. So the 5 there is what we found. Now we can move on to the next part. Now, since we know that B has to add up to 19, we can now find the unknown T there in the middle. Because since we found the 5 in B, now we can find the other unknown in B, which is T there in the middle. So use subtraction. So 19, which is the totality of B, minus the 10, minus the 5, minus the 4, leaves us with, believe it or not, 0. So the value of T, the value of the triple intersection there in the middle, is 0. Great, now we only have one more thing to find, and that is the part of the intersection between A and C there in the blue. And we can do this using A. Since we know that A has to equal 10, we can just subtract to find that last unknown. So 10, which is the entirety of A, we're given, minus the 3, minus the 4, minus the 0, leaves us with 3. So the unknown there in the blue section is 3. And that's that. Great work. That's kind of a hard one because, again, we had 3 sets there with 2 unknowns. So we kind of had to use that little trick there between A and C that allowed us to find the part of B, and then we can actually work backwards from there. Again, Venn diagrams are all about practice. You just have to do them. You see patterns that develop in the questions and things of that nature. So, again, it's just practice. So a few Venn tips from me. Number 1, write out everything the problem gives you. Use a lot of paper, make lists, because it helps you tremendously. The more you put on paper, the less you have to keep in your mind at any one time. Using the numbers in the original problem, make a list of everything else you can find out on your own. So in both these problems, there were things that weren't given to us in list form, but by looking at the numbers in the Venn diagram, we could write down. So always look for those things as well. Now sketch out on your own intermediate diagrams so you can go back and trace your work. So you've noticed in this video, I had a Venn diagram for every step. And that way I could go back and look at what I was doing and see how the parts go together. So make diagrams along the way. Now try to start in the center, which is the overall intersection, if at all possible, and then work your way outward, because that's the most specific. So the triple intersection there in the middle, when you have 3 sets, that's the most specific. So you can use that specific part to find larger parts as you kind of spiral out from there. So always start in the middle if you can. And combine regions temporarily if it will help you find a different unknown. So that's the trick we used in the second problem. So we used that part of A to find the part of B that we were missing. Even though that little part we put together comprised 2 unknowns, we still knew that they had to add up to 3, whatever they were, but that allowed us to find that part of B that we were missing. Then we could go back and find the rest. And finally, be patient. Venn diagrams are deceptively simple, but they require a method of thinking that we really aren't used to, because you have to do it visually in your mind. You have to think of the Venn diagram in pieces and layers and things like that. So it's kind of like part puzzle, part chess game, part math problem. So just be patient and work through it methodically. Okay, so that wraps up our first video on Venn diagram practice. So I wanted to expose you to 2 problems that come up quite a bit when working with Venn diagrams in your finite math class. Now in the next video, we're going to do word problems. So you have the additional step of having to extract the information from the words in the problem, then set up your own Venn diagram and go from there. So it's that added complex step of figuring out what the Venn diagram looks like just from the words and numbers in the problem. Okay, so just keep in mind, if you are struggling in your class, I want you to stay positive and keep your chin up. You're a smart, talented person, and you may have just hit a temporary rough patch, because Venn diagrams can be difficult, even for students who had calculus in high school. It's just a different way of thinking. Now keep in mind that these videos are meant for individuals who are new to finite math. So if you're looking for more advanced stuff, you can check out my later videos or my other videos or other people's videos. But I want you to have a firm understanding of the basic concepts. If you liked the video, please give it a thumbs up, put it on a playlist, or share it with colleagues or classmates. That does encourage me and other screencasters to keep making our videos. If you think there's something I can do better, leave a constructive comment below the video, and I'll try to take that into account for future ones. So finally, just keep in mind that because you're on here trying to improve yourself, trying to get smarter, trying to do better in school, or trying to run your business more efficiently, that's what really matters, okay? So, thank you very much for watching. I wish you all the best of luck in your studies or in your other work, and I look forward to seeing you again next time.